Good morning, children. I welcome you all to the chemistry class. Today also we are continuing with the chapter metals. So in the last class we were discussing about the different physical properties of metals. Today we are discussing a new topic. So as you all know, if you look around your home, you can find that if you have a cycle there, or if you have iron objects in your home, you can see that after we are using it for a long time, we can see a brownish color coating is formed on the substances which are made up of iron, and we call it rust. So why do rust happens, or what causes rusting? Similarly, your anklets which are made of silver slowly turns into black color. Then copper vessels which are kept in our home, they also changes its color. They have after some time you can see that there is a green coating on the bottom of the copper vessels. Now why does this happen? So some chemical reaction is taking place to form this color change. So today we are going to study about the chemical properties of metals. Now as you know that if you are keeping, you know that sodium is a soft metal, isn't it? You all know that sodium is a soft metal. This sodium, if you are cutting this sodium into two halves, it shows metallic luster that we studied in the last class. But this sodium, if you are keeping it exposed to air for some time, you can see that the color fades. Okay, it gets tarnished. Tarnished means the color gets faded. It loses its luster. Similarly, aluminium. Okay, aluminium also. Aluminium vessels, some vessels which are made of aluminium, if you are keeping it outside for a long time in contact with air, you can see that it loses that lustrous property. Not quickly, but after a few hours or few days, you can see that it loses its lustrous property. Why? Because some metals have the capacity or have the ability to react with the moisture content which is present in the air, the oxygen which is present in the air. Now just think that I am cutting a piece of sodium. Okay, we are going to find out how metals react with water. Okay, how metals react with water. Now I am taking a piece of sodium. Okay, sodium is a very reactive metal. This sodium, when I am putting this sodium in a piece of sodium in some water, you can see that this sodium reacts vigorously, quickly, spontaneously with water to form its hydroxide, and hydrogen gas is liberated. Okay. So likewise, if you take potassium, you can see that potassium reacts with water to form potassium hydroxide and hydrogen. Okay. So here 2 and 2. I hope it is balanced. Yeah. Okay. So here you can see that this sodium reacts with water to form sodium hydroxide and hydrogen. Similarly, potassium, which is a metal, reacts with water to form potassium hydroxide and hydrogen. Now just think that I am putting a piece of copper. You know, copper is also a metal like sodium and potassium. But when I am putting a piece of copper in water, it doesn't react. Okay, copper is a metal, but it doesn't react with water. Why? Because these metals are reacting with water based on their reactivity. Some metals are very reactive, some metals are not that reactive. So based on that, some metals will be reacting with water, or they will undergo a chemical reaction with water very quickly. Okay. Now next is about how the metals are reacting with acids. Okay. Then metals react with acid. Okay. Now I am taking some metals like zinc, iron and magnesium. Now among these metals, magnesium is a very reactive metal. Okay. Among these metals, magnesium is a very reactive metal. Now I am taking a hydrochloric acid. I am taking hydrochloric acid. This magnesium, which is a reactive metal, reacts with the acid to form magnesium chloride and hydrogen. Okay. Then zinc, when reacts with HCl, forms zinc chloride and hydrogen. Hydrogen gas is released. Iron also reacts with HCl, but not that quickly as magnesium. That you have to understand. Magnesium, the reaction between magnesium and this acid takes place very quickly. But in iron and HCl also, the reaction takes place, but not that much quickly. So you have studied that, you will be studying this in your future classes when you go to 9th standard, why this reactivity and how these elements are reacting, you will be studying in the 9th standard. Okay, so iron also, the reaction will be taking place, ferric chloride and hydrogen is released. Yeah. Okay. So this, how can you identify this gas is hydrogen? So if you keep a burning splinter on the mouth of the test tube, you can identify the gas hydrogen with the pop sound. Okay, you can identify hydrogen with the pop sound. So that is how we are identifying whether the gas given is hydrogen or not. Okay, so metals, don't think that all the metals are reacting with water, acid. All metals don't react with acid. Copper doesn't react with acid. Gold, silver, platinum, they are not reacting with
What happens when metals react with acids? We have taken samples of magnesium, aluminium, zinc and copper. Add the samples into the beaker containing dilute hydrochloric acid and observe the formation of bubbles. We can see that the rate of formation of bubbles is the fastest in the case of magnesium. The reaction is the most exothermic in this case. The reactivity decreases in the order magnesium, aluminium and zinc. Metals react with acids to give us salt and hydrogen gas. In the case of copper, no bubbles were seen and the temperature also remained unchanged. This shows that copper does not react with dilute hydrochloric acid.
Download Spark Learning app.
Reaction of metals with water. Activity. Take the sample of the same metals as in the earlier activity to perform the activities given here. Put some pieces of the sample separately in beakers half filled with cold water. Which metals reacted with cold water? Answer. Magnesium reacted with cold water. Did any metal catch fire in water? Answer. Metals like sodium react vigorously with water and catch fire. Does any metal start floating after some time? Answer. Calcium starts floating after some time. Observation. Answer. Metals like aluminium, iron and zinc do not react either with cold or hot water, but they react with steam. Metals like potassium and sodium react vigorously with cold water. Sodium reacts with water to evolve hydrogen, which immediately catches fire, producing a lot of heat. It is an exothermic reaction. 2K plus 2H2O gives 2KOH plus H2 plus heat. 2Na plus 2H2O gives 2NaOH plus H2 plus heat. Calcium reacts with water less vigorously, hence the heat evolved is not sufficient for hydrogen to catch fire. Instead, calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Ca plus 2H2O gives CaOH twice plus H2. Put the metals that did not react with cold water in beakers half filled with hot water. Note your observation. Answer. The reactivity decreases in the order. Magnesium is most reactive. It is more reactive than aluminium, which is more reactive than iron, which is more reactive than lead, which is more reactive than copper. Magnesium reacts with hot water to form magnesium hydroxide and hydrogen. Magnesium also starts floating since the bubbles of hydrogen gas stick to its surface. Write the equation for the above reactions. Mg plus 2H2O gives MgOH twice plus H2 gas. For the metals that did not react with hot water, arrange the apparatus as shown over here and observe the reaction with steam. Metals like aluminium, iron and zinc do not react either with cold or hot water, but they react with steam to form metal oxide and hydrogen. 2Al plus 3H2O gives Al2O3 plus 3H2 gas. 3Fe plus 4H2O gives Fe3O4 plus 4H2 gas. Metals like gold, silver and copper do not react with water at all.
Okay. So, in olden times, or if you have your grandparents at your home, you have heard that your buttermilk, no curd, you should not be kept in aluminum vessel. Then this steel knife should not be put, iron knife should not be put in, or iron knife should not be cut, you should not be used for cutting this lemon. Why? Because inside the lemon, now we studied about how the metals are reacting with acids, right? Now, in lemons, as you all know, it is having an acid. What is that? Yes, citric acid. So, when we are using an iron knife for cutting this lemon and all, what happens? This metal will react with acid, which is present in lemon. Similarly, buttermilk. Buttermilk is curd. Curd contains an acid, lactic acid. So that if you are keeping this curd in aluminium vessel, what happens? This acid will be reacting with the metal, and slowly the aluminium, it forms a chemical compound of aluminium, and if you are consuming it, what happens? It will cause food poisoning and other health issues. Now, when you are constructing a home, we keep windows, doors, etc. in our home, and we all paint them, isn't it? Is it just for beautifying our house? We are painting the window bars and all? No. We are painting them to prevent it from corrosion. Corrosion means, you know, in air is a mixture of gases. Air contains oxygen, nitrogen, then what? This moisture, etc. So what happens is that this metals, iron we are using for making this window bars, this iron slowly what happens? It reacts with the moisture which is present in the air, the oxygen which is present in the air, and it turns into an oxide form. Okay, it turns into an oxide form. So rust is hydrated, iron oxide, That is 2Fe2O3, 3H2O. This is hydrated iron oxide. Hydrated iron oxide is otherwise known as rust, and the chemical form of iron oxide is 2Fe2O3, 3H2O. That is, this iron slowly reacts with this moisture, oxygen, and chemically turns into iron oxide or rust. So when we go to this seashore areas, though in those areas the particles get rusted very easily, very quickly. Why? Because in that area, inside that moisture content, salt content is also more. So this salt will be acting as a thing which is increasing the process of rusting. So when you go to humid areas, that is in seashore areas, humidity is more. In that humidity, in that moisture content, salt content will also be more. So salt will be triggering, or it will be increasing the rusting process. Similarly, the sodium and potassium. You know, sodium and potassium are soft metals, isn't it? When you go to a lab, you can find that sodium and potassium are kept in kerosene. They are not kept outside. Why? One reason, they are very reactive, that is the thing. Second one is that this sodium and potassium, even though they are very reactive, when they are kept outside, what happens? It readily combines with oxygen to form oxide, then with water or the moisture vapor to form hydroxide, and finally to the carbonate form. So quick the reaction takes place. So because of that, to prevent that reaction, to prevent that rusting, we keep them in kerosene. Now, what are the different ways by which we can stop this or reduce this rusting? One thing we are doing is painting. Second one, we will be putting grease, isn't it, for that on the machine parts and all. We will be using this applying grease. Then there is another technique known as galvanizing. Galvanizing means we are coating the layer of zinc over iron. We are coating a layer of zinc over iron. That technique is known as galvanizing. So these are the different ways by which we can stop rusting. So today in this class we have discussed about how metals are reacting with water, metals are reacting with acids, and how rusting takes place. in different metals and how we can prevent them. So with this video, the chapter metals is over. Thank you.